Hi there. You have probably met the remainder and factor theorems in high school. In this video, we're going to take a look at a number of examples where we apply the remainder and factor theorem. Now, the remainder theorem tells me that if you divide a polynomial fx by a linear factor ax minus b until it is free of x, then the remainder is given by f of b over a. So where does that b over a come from? If we take ax minus b and equate it to 0 and solve for x, we get that x is b over a, and therefore the remainder is given by f of b over a. Now, the remainder theorem also tells me that f of x can then be written as the divisor times the quotient plus the remainder. The factor theorem is just a corollary of the remainder theorem. So if you've calculated f of b over a and find that the answer is 0, then the factor theorem tells me that ax minus b is a factor because it means the remainder is 0, and also that we can factorize fx. In activity 1, we're asked to divide fx equals 6x cubed plus 35x squared plus 5x minus 8 by 2x plus 1 with long division. So 2x goes into 6x cubed, 3x squared times. If we multiply 3x squared by 2x plus 1, it gives me 6x cubed plus 3x squared. If we now subtract, it gives us 32x squared plus 5x minus 8. Since 32x squared has a degree that is higher than the divisor, 2x plus 1, we have to repeat the process another time. So 2x go into 32x squared, positive 16x times. If we multiply positive 16x by 2x plus 1, it gives us 32x squared plus 16x. If we now subtract, we get minus 11x minus 8. The degree of minus 11x minus 8 is still greater or equal to the degree of 2x plus 1, so we have to repeat the process again. 2x goes into minus 11x, negative 11 over 2 times. If we multiply that out, it will give me minus 11x minus 5.5. And if we now subtract, minus 8 plus 5.5 will give me minus 2.5. Minus 2.5 has now degree 0, which is less than the degree of 2x plus 1, and that is my final remainder. So please note that 2x plus 1 is the divisor. 3x squared plus 16x minus 11 over 2 is the quotient, and minus 2.5 is the remainder. We have to write fx now as a combination of the divisor, the quotient, and the remainder. Now, if you forget how, then just think of a simple example such as 4 goes into 13, 3. 3 times 4 is 12. If I subtract that, the remainder is 1. And 13 can therefore be written as 4 times 3 plus 1, which is the divisor times the quotient plus the remainder. So that means we can write fx as the divisor, 2x plus 1, times the quotient, 3x squared plus 16x minus 11 over 2, plus the remainder. And if we divide fx by 2x plus 1, on the first term, the 2x plus 1's will cancel to leave me with 3x squared plus 16x minus 11 over 2. And if we divide the last term by 2x plus 1, it will leave me with minus 2.5 over 2x plus 1. Now, remember that this is the form in which we use long division most when we use long division as part of an integration technique. We're also asked to confirm the remainder theorem by the remainder that we just got, this remainder of minus 2.5, by using the remainder theorem. So if we look at 2x plus 1 and equate it to 0 and solve for x, we get that x is minus a half, and therefore we have to calculate f of minus a half. And if we simplify that, we do find that the answer is minus 5 over 2, which is negative 2.5. So our remainder is confirmed by the remainder theorem. In activity 2, we are asked to find the value of a if fx equal 2x squared plus ax minus 5 is divided by x minus 1 with a remainder of negative 4. So if we interpret the information that is given, so we're told that when f is divided by x minus 1, it gives a remainder of minus 4, can interpret it as f of 1 is equal to minus 4. If we calculate f of 1 and equate it to minus 4, we can now solve for a, and that will give me that a is equal to negative 1. In activity 3, we're told that if mx is divided by 3x minus 1 and x plus 2, the remainders are negative 3 and negative 10 respectively. So note that we have two unknowns. We have unknowns a and b, and that means we'll need two equations to solve simultaneously to find the values of a and b. Now we're told that when mx is divided by 3x minus 1, the remainder is minus 3, and so that will give me the equation m of a third equals negative 3, and then when mx is divided by x plus 2, the remainder is negative 10, which will give me that m of minus 2 is negative 10. If we calculate m of a third and equate it to minus 3, we get the equation a ninth plus ninth a plus a third b minus 2 equals negative 3. Now, I don't like this equation because of all the fractions, but luckily it's an equation, and you can multiply an equation right through by the LCD, which is 9, to give you that 1 plus a plus 3b minus 18 is equal to negative 27. If we now get a plus b alone on the left-hand side and all the constants on the right-hand side, it gives me that a plus 3b is minus 10, and I'll call that equation 1. If we calculate m of negative 2 and equate that to minus 10 and simplify, we get that 4a minus 2b is equal to 16. Now we see that we can divide right through by 2 to give me equation 2, which is 2a minus b equal 8. So we have two equations that we can solve simultaneously. I'm going to use the elimination method. We'll write equation 1 down first, and then take equation 2 and multiply it by 3 and write that below equation 1. So that will give me 6a minus 3b equal 24. If we now add the two equations, it gives me that 7a is equal to 14, which implies that a is equal to 2. I can now substitute a equal 2 into equation 2 to give me that b is negative 4. Hence, we have solved this question, as the question that was asked of us was simply to calculate the values of a and b, and we have done so. In activity 4, we are told that x minus 1 and x minus 2 are factors of px, and we're asked to determine a and b and the other factor. I'm not going to do this question in detail, but we'll just take a quick look at how it's done. So if we are told that x minus 1 and x minus 2 are factors of px, then we can make two deductions. We can make the deduction that p of 1 is 0 and that p of 2 is 0. If we use these two pieces of information, p of 1, calculate that, equate it to 0 and simplify. P of 2, calculate that, equate it to 0 and simplify. We have two equations that we can solve simultaneously to find that a is 1 and b is 2. Now, we were asked to determine a and b, but also to determine the other factor. So if we write px, which is x cubed minus 2x minus 1x plus b plus 2, b is 2, and we already know that we have factors x minus 1 and x minus 2, we only need the third factor. You can get this third factor by long division, but that is quite a lot of work, and in this case it will be much simpler to find this third factor by inspection. Since we already have, if we look at the first if we look at the product of the first terms of each bracket, then x times x will give me x cubed. And if we look at the last term, then -2 times -2 is already +2, which means I have to multiply that by +1 to give me a +2 as the final term in my expression. Let's just double check that x plus 1 is indeed a factor. So if we calculate p of -1 and simplify, we do get that p of -1 is 0, which confirm that x plus 1 is the other factor. In activity 5, we're told that x squared plus x minus 6 is a factor of gx, and we're asked again to determine p and q and factorize g of x. We've only been given one factor, but there's two unknowns, p and q. However, we see that we can factorize x squared plus x minus 6 as x plus 3, x minus 2. And if x squared plus x minus 6 is a factor of gx, then x plus 3 must be a factor of gx, and also x minus 2 must be a factor of gx. So again, we have if x plus 3 is a factor of gx, then g of minus 3 is 0. If x minus 2 is a factor of gx, then g of 2 is 0. And we have two equations that we can solve simultaneously to give us that p is -3 and q is 30. Now we still have to factorize g of x. So if g of x is written as x plus 3 times x minus 2, our third factor will be a linear factor. So we need the product of the first three terms to give me 2x cubed. So we have an x times an x. That means my first term has to be a 2x. And my last three, positive 3 times -2 times whatever must give me positive 30. And that means my third factor will be 2x minus 5. To confirm this, we can calculate g of 5 over 2 and see that it is 0, which confirms that 2x minus 5 is the other factor and gx is fully factorized. In activity 6, we are asked to prove that a minus b plus 2 is a factor of f of a. So if we have to prove that something is a factor, then we need to prove that f of something is equal to 0. But what is that something? If we look at a minus b plus 2 and equate it to 0, and then notice that f is a function of a, it means we need to solve this expression for a, so that gives me a is b minus 2. So what we need to show is that f of b minus 2 is equal to 0. So if we calculate f of b minus 2, it gives me b minus 2 squared minus b minus 2 plus b squared plus 5b minus 6. If we simplify that, b squared minus 4b plus 4 minus b plus 2 minus b squared plus 5b minus 6. We see that the b squared minus b squared is 0, minus 4b minus b plus 5b is 0, plus 4 plus 2 minus 6 is also 0. So, since f of b minus 2 is 0, it proves that a plus b minus 2 is a factor of f of a.